Hi guys, have you noticed that a lot of differentiation questions seem to talk about gradients and tangents and normals and you just don't really know how they link? Well, this is the video for you. Hi guys, I am Charlotte from Studentium, here to make your maths and science revision stress-free and simple. Check out this video to find out several things. We're going to work out what the relation is for differentiation and gradients. We're going to learn how we can use differentiation to work out the tangent equations and also the equation of normals, everything that you need. Make sure you subscribe to get the next video in the series. Now let's watch to see the answer to all of our questions. Hiya there. So now we're going to have a look at gradients, tangents and normals, which is basically where differentiation meets coordinate geometry. And we're going to have a look at a bit of the theory, the key facts you need to know, and then we'll have a look at some worked examples. All right, so here with gradients and normals, we know how to find the gradient of a point on a curve now, don't we? That is through differentiation. And now we're going to use that fact to be able to find the equation of tangents and normals, okay? So first off, let's just recap. What is a tangent and what is a normal? So a tangent is just a straight line that just touches a point on a curve. So you can see it here in this diagram, a little curve and a tangent. So a normal, on the other hand, at any point is just the line perpendicular to the tangent at that point. So how would we find the equation of a tangent? So this is where your coordinate geometry comes in, and we're going to use this equation that we learned there, which is that y minus y1 equals mx minus x1. And m is the gradient in this case. x1 would be the x coordinate of any point given in the question, and y1 would be the y coordinate of that point. So let's put this into practice in a question. So let's find the equation of the tangent of y equals x squared plus 5x at the point x equals 5. So I'm going to run you through the standard steps. So first you're going to differentiate to find dy dx. Then you'll substitute the x coordinate given in the question to find the gradient at that specific point, and that will be what your m is. Then the x coordinate given in the question is our x1. In this case, we will need to substitute that x into our y equation, the original one, that will give us our y1. And then we put it all into our equation of a straight line. So let's have a look at how that turns out. So first we'll differentiate, which differentiating this, remember we times by the power and take 1 away from the power, we get 2x plus 5. So if we now substitute the x coordinate into that, so we know that we're looking specifically at the point where x equals 5, let's find the gradient at that point of x equals 5, and we get there 15 for the gradient. So then for question part 3, the x coordinate given in the question is your x1. So we know that now. We know the x1 for when we go to our equation of a straight line. And we can substitute x into the equation of a curve from the question to get our y1. So y equals x squared plus 5x. So substituting that in, putting 5 everywhere where we see x, we get 50 as our y coordinate. So now we substitute everything into our equation of a straight line. And we know all these things. We know that the gradient is 15, we know that the x coordinate is 5, and the y coordinate is 50. So that equation of a straight line, plugging everything in, and then giving a little bit of a rearranging, I get y equals 15x minus 25 for the equation of the tangent. So a really definitive little method there, looking great. So let's now have a look at how we'd find an equation of a normal. And the method is essentially the same. There is a very, very small difference. So the only difference is the gradient, because as we saw right at the beginning, that the gradient of a normal is perpendicular to the gradient of a tangent. And luckily, we've learned earlier, haven't we, back in coordinate geometry, that the gradient of the normal, so something perpendicular, is the negative reciprocal. So if we can get the gradient of the tangent, like using the method of differentiation that we had before, we can easily work out then the gradient of the normal by just doing minus 1 over the gradient of the tangent. And that's our key fact to take away here. So we've just got one extra step in our method. So this here is a typical question. Find the equation of the normal of y equals x cubed plus 1 at the point x equals 1. So we are still going to differentiate to find dy dx. You will substitute the x coordinate given in the question to find the gradient at that point, but then we do the negative reciprocal of this gradient to get the gradient of the normal, which in this case will be our m. The x coordinate given in the question is still our x1, and we can substitute that back into the original equation, y equals x cubed plus 1, to get our y1 coordinate. And then everything, just like before, goes into our equation of a straight line. So let's do that then. So differentiating, so timesing through by the power and taking 1 away, leaves us with 3x squared. Putting our x coordinate into that, we'll substitute 1 in, and we just get 3 for that gradient. But we need to do the negative reciprocal of that to get the gradient of the normal, okay? So by doing that, we get that the gradient m is minus 1 over 3, and that is the gradient of the normal. The x coordinate is our x1, so we know our x1 is 1. And then we can substitute that x back into the original equation to get our y coordinate. So in this case, y1 will be equal to 2. And then finally, we substitute everything back into our equation. So we know that x1 is 1, x2 is 2, and the m is minus 1/3. So putting that all in to our equation of a straight line, we get left with y minus 2 equals minus 1/3 x minus 1. Which, if we want to, we can rearrange that. And here I did that, and I got y equals minus 1/3 x plus 7/3. So that is our equation of a normal. So the best thing for you to do now is to go away, use the methods that we've put together in this video, and see if you can do it yourself. And I would be surprised if you can't, to be honest, because this is our crystal clear method. So really good work in following along, and give me a follow, and then you can get to see lots more videos. I'll see you later. Bye. I really hope that that has cleared some things up for you guys, and that you're feeling much, much clearer now on why we differentiate, the fact that differentiation gives us the gradient of a function at a specific point, and how we can then use that together with our coordinate geometry to work out equations of tangents and normals. Well, good work everyone. Make sure you subscribe to get the next video in the series, and I will speak to you then. Bye.